Hello and good day, pre-algebra. We are starting with a new book, with a new unit, in a new year, and new opportunities for glory. You don't have book 2 yet. You'll actually get it when you return on January 11th, but I did hand out the pages that we'll be using. They're also posted in Google Classroom if for whatever reason things got misplaced and you need to print them out. But we'll be starting Unit 4, which let's kind of take a preview of what's coming up here in Unit 4. Start with the PO24, and we'll go through PO29 there. And if you kind of read through these objectives, there's a word that's going to show up over and over and over again, and that word is function. Unit 4 is all about functions. And if you've not heard of a function before, basically it's an equation that can be graphed on the coordinate plane. So think back to 6th grade and the x-axis and the y-axis and the xy order pairs and plotting the points, and maybe you talked about things like slope or x-intercept or y-intercept. We're going to be kind of setting the stage for us to be graphing equations, and it starts with functions. Okay, so that's kind of what this unit is going to focus on. Before we go any further, actually, I do have a couple administrative items to talk about here. There is going to be a Google quiz for each lesson that we do this week. Once you're done watching the video, hop over to Google Classroom and complete the quiz. I know we only have a half hour for classes here, so I'll try and keep this video right around 20 minutes so that you have some time to take the quiz before your next class. But you do need to get 100% on the quiz in order to receive credit for it. Math packet number 6 was posted today. You'll get a paper copy of it when you come back on the 11th, but if you want to get a jump on it, you can read through it or print it out or whatever and start to work on it now. I will post kind of a get you started video for that later on in the week. Grades from Unit 3 have been posted. So if you want to hop on to Educate and take a look at any retakes that you might want to start to work on practice work for, hopefully you still have your book 1 from before break, because that's where the practice work for Unit 3 is. Don't email me practice work or anything. We're not going to do retakes over email like we did at the end of the try. We'll have a retake day next week when you come back, and I'm also going to have more time after school for extra help and retakes and things like that. But grades are posted, so you can see where you stand there. No con is going to be due this Thursday. I will assign your next con on Thursday, which will be due the following week. So nothing due for Khan Academy this week. I will assign it on Thursday, and we'll pick it up due next week. So I think those are all the announcements that I have for you. If anything else pops up, I will just interrupt myself and give it to you. But looking at PO24 here, creating a function table for a given equation. Perhaps you haven't heard the term function table, but if you've heard the term XY table, or if you've ever been asked to write a rule for a table, you've been dealing with function tables. Okay, function tables usually have an X and a Y variable because they relate to the coordinate plane, right? The X-axis and the Y-axis. And the X variable is called the input because the input is the value that you plug into the equation. Okay, and again, you are plugging that value in for the X variable. So the input, if we have an XY ordered pair here, the input is that X value, and it's the thing that you get to pick, right? It's what we are testing. If you think about this as kind of like a science experiment, the input is the hypothesis, right? It's what we are testing, okay? And it's a value that you get to pick. The output is the value of the equation with a given input. Okay, so you plug in the input, you get out the output. The value of the equation with a given input. So in our XY ordered pair here, the output would be that Y variable. So just as kind of a simple example here before we get down to the practice below, if we have an equation that is y equals x minus 10, okay, and I want to know, well, what's the value of the equation? What's the value of x minus 10 when x is 15, right? What I've just done is I've put the input 15 in for x in the equation, and it turns out that equation, I'll show 25, equals 5, okay? 5 is the same as 15 minus 10. That is the output. So we plugged in 15, and what we got out of it, the value of the equation when x is 15, is 5. So on the coordinate plane, this would represent the ordered pair, 15, 5. Right? The x value, what we plugged in, our input, was 15. The y value, what we got out of it, our output, was 5. Okay? And a function table it's an organized table that relates the input to the output, okay? And what it can do is it can help identify the rule for the table. The rule for the table. And the rule of the table is basically the equation that's being used. So going back to our example that we kind of talked about previously here, the rule, if we were to make a function table for that equation, that would be the rule. What are we doing to x to get to y? We're subtracting 10, right? X minus 10. That is the rule of that function table. Now, in this exercise, I am giving you the table. You kind of look down here in the practice section that we'll get to shortly here. I'm giving you the rule. I'm giving you the equation, and you'll be asked to create a function table that follows that particular rule. And like I said, the best part is you get to pick your own input, right? I recommend that at least for the first couple, you use the same values for x that I use just to stay consistent here. But once you start to get going with this on your own in future things, you'll get to pick that input yourself, okay? All right, let's practice here. The directions say, create a function table with at least 4 outputs for each equation given. So what we're going to do here, our rule is y equals x plus 3. And what that means is that for every value that we plug in for x, we're going to add 3 to it to get the output, which is the y. So we're going to make an xy table. You may have seen them look like this. Okay, xy table. And we're just going to pick values for x to plug into it. My favorite number, my lucky number, is 21. So if x is 21, this equation becomes 21 plus 3, which equals 24. And that would be the output. When x is 21, y is 24. Okay. See, my wife was born on August 22nd, so we'll plug 22 in there. If 22 is our value for x, that's what we're plugging in, 22 plus 3 is 25. And in this particular example, you might notice here that our x value increased by 1, and so did y. That's not always going to happen, right? Because it depends on what the rule is. But in this case, whatever we pick for x, we just add 3 to it to get y, and we see that relationship there. One more here. Let's see. Mario Maker related. In Mario Maker right now, in a particular challenge that I'm doing, I have 79 lives. So I'll pick 79 to plug in there. If x is 79, 79 plus 3 is 82. That's going to give us the output of 82. Okay. I know it says with at least 4 inputs, outputs. I wrote too large here, so I'm only going to have 3 here, so you can add a fourth one of your own choosing there. But basically, whatever you plug in for x, y is going to be 3 greater than that, because we are adding 3 to x to get y. And just as a sidebar, because this will come back later on, I mentioned before about ordered pairs and coordinate plane and things like that. This essentially, what a function table does is it gives you ordered pairs, right? We can plot these points on the coordinate plane. Those blue marks in the middle are supposed to be commas there, but 21, 24 is one point. 22, 25 is a second point. 79, 82 is a third point. These are all ordered pairs that relate this function and then can be graphed on the coordinate plane. Okay. Next one, y equals negative 2x. Y equals negative 2x. Again, we're going to make an x, y table here. Okay. And the rule in this case is that whatever x is, we're going to multiply it by negative 2 to get y. Right? Negative 2 times x. That's what y equals. Y is negative 2 times x. So if x equals, we'll say 1, well, negative 2 times 1 would give us a y value of negative 2. Okay? If x is positive 3, well, negative 2 times positive 3 is going to give us a y value of negative 6. Okay? Let's say that x is 8. Negative 2 times 8 is a negative 16. And just for funsies here, let's make x a negative value. If x is negative 5, negative 2 times negative 5, a negative times a negative, that's going to give us a positive 10. So again here, what we plug in for x is our choice, well, my choice right now, but our choice, that's the input, and then the y value is the result we get from the equation after plugging that value in for x. And again, we've got ordered pairs here. If we were to plot this on the coordinate plane, 1, negative 2, 3, negative 6, 8, negative 16, negative 5, and positive 10. Okay. Sometimes you might see, more complex equations here. We have a two-step equation up here next, y equals 5x minus 8. You might see an xy table with your x, and then a section for the rule, and then y. And I'm actually going to give myself a little bit more space in that middle to write here, because I know myself, if I don't do it, I'm going to run out of room, okay? And then y here. And the value of this is that after you plug in something for x, we'll start with 3. What's the value of the equation when x is 3? It can be kind of helpful to write that equation out with 3 plugged in. What are we doing here to calculate y? We're plugging 3 in for x. So instead of 5x minus 8, it becomes 5 times 3 minus 8, which is 15 minus 8, gives us a y value of 7. So when x is 3, y is 7. What about when x is 6? Well, now the equation changes to be 5 times 6 minus 8. 5 times 6 is 30. 30 minus 8 is 22. Okay? And if you're wondering here, well, wait a minute, we went from 3 to 6, so we doubled 3 to get 6. Shouldn't this be 14 then? You just double 7? No. Okay? That's not the relationship here. We aren't looking for a connection between the 3 and the 6 and the 7 and the 22. Okay? We're looking for what is the value. I'll just cross this out. I'm going to erase everything here. What is the value of the equation for a given input? Okay. So actually, what I'm trying to say here is actually do the work. Actually plug it in. Don't try and make any assumptions based on prior observations here. What if x is 12? 5 times 12 minus 8. Well, 5 times 12 is 60. 60 minus 8 is 52. Okay. And finally, what if x is, again, just for funsies here, we'll throw in a negative number, -4. So we have 5 times -4 minus 8. 5 times -4 is a -20. -20 minus 8 is a -28. Make sure you're going in the right direction there, right? -28. Okay. The next one, y equals x squared minus 10. Again, xy table here. If you want to put the rule in the middle, that's great practice. You know, what happens when x, and here's an example too of being able to pick your own inputs can kind of be important here, because if we were graphing these on the coordinate plane, which eventually we will, why wouldn't we want to pick a value for x that's like 50, right? 50 squared, no thank you. Our values are going to get pretty large, right? So if you get to pick your own value, keep it simple. Keep it something like 4 is not too bad there. 4 squared minus 10. 4 squared is 16. 16 minus 10 is 6. There we got that. If x is 5. 5 squared minus 10. 5 squared is 25. Minus 10 is 15. 7 squared. 7 squared minus 10. 7 times 7 is 49. Minus 10, 39. Okay. Again, that input, output. When x is 4, y is 6. When x is 5, y is 15, and so on. The last one here. Save the best for last, because this one, I can write that better. With that fraction, you can really be smart in the values that you choose. That'll look like 1/9. Third time's the charm. That looks like close enough to a 4, I guess. Okay, and we'll put our y over here. So, looking at this, I see here in my rule that I'm going to be multiplying x by 1/4. So would a number like 3 be a very smart value to plug in here for x? 1/4 times 3. I mean, you could do it, yeah, but it's not going to work out cleanly. We're going to get a fraction answer or a decimal answer. Okay, if you want to deal with them, fine. But if you get to pick, why would you, right? Let's pick a number like 4. 1/4 of 4 plus 7. Well, a fourth of 4, you have 4 things. You want a fourth of them. That's 1 plus 7. 1 plus 7, y is 8. Okay. What would be another smart value to choose here? What do you think? Just something even, like 6, 1/4 of 6. I have 6 things. I want a fourth of that. That's not very friendly. How about 8? 1/4 of 8. I have 8 things. I want a fourth. A fourth of 8 is 2. 2 plus 7 equals 9. Okay. What would our next smart value be here? 4, 8. Maybe you can sense a pattern coming along here. 12? 12 is good. 1/4 of 12 is 3. 3 plus 7 is 10, right? What's the key here? What do 4, 8, and 12 have in common that we can relate to 1/4? Well, they're all multiples of 4, right? Since our denominator of this fraction is 4, choosing multiples of 4 is going to be smart values to pick. We're going to avoid fractions, avoid decimals in our calculations. If that denominator was 3, then you'd pick multiples of 3, right? 3, 6, 9, 12. If the denominator was 7, pick multiples of 7. 7, 14, 21, 28, etc. Right, and that's going to keep your values pretty clean for you. My goal was to get to Mr. Heavy Pencil section, or sorry, Mr. Real World Globe section there, but I did say I was going to keep this video to 20 minutes. I think I'm coming up on about that time, so we'll stop here. Your Google quiz will only be on this section here and the definitions of inputs and outputs and function tables and things like that. So hop on over to Google Classroom and take care of that. And that's it for today. If you have questions on this, I do have office hours starting at, I believe, 1 o'clock. Pull up my schedule here. Office hours at 1:30, actually, 1:30 to 2 o'clock. Of course, my email is always open. But if you did want to Zoom something, you want to meet in person, let me know. Set up an appointment between 1:30 and 2, or also just post a link and anybody can just hop on in. So check Google Classroom for that. But please do contact me if you have questions so we can keep up with Unit 4 and not fall behind. So that's how you math, folks. Have a great day. Do not forget to like and subscribe. Bye.